Team, you ready to start? All right, show me that you're ready to start by stop talking. Okay, so we are starting on thermochemistry today. Thermochemistry is the build on from structure and bonding from last year. So Chem 2.4, this one now continues into Chem 2.3. So FYI, that's where you're kind of bridging your knowledge. So you should hopefully have some prior knowledge from it from last year. It is similar in a lot of ways, but there's definitely some new stuff to it. The other thing I want to add about thermochemistry is that it is a bit of a Frankenstein topic, just like the structure and bonding was as well. They've really mixed and matched it. They have taken old standards that used to exist and kind of squashed them together, and so it's not fun in that sense. The good news is that there is a lot of rote learning you can do for this standard, so that's the good news. It's much, much easier to get achieved on this than organic. It's not as intertwined together as well as organic. Because if you can remember with organic, it's very, like, you need kind of to know everything to be able to answer the questions, whereas this, you can learn it as categories and be done. So, this is Chem 3.4, known as thermochemistry. It is also worth 5 credits like the organic one, so it doesn't matter which of the 2 exams you sit. Either way, you'll still be able to get 14 credits because you have the 9 from the internals for chemistry plus these 5, 14. So that's why I keep saying you have to pass 1 exam in order to pass chemistry as a pure subject. What else did I want to add? That is also the reason why I'm putting the hard line of you need to pass organic in order to be able to do both exams. If you don't pass organic, then I'm going to make you choose either do thermo or you do organic as your one choice. So like I said, it does fall into 3 categories. If you guys remember last year, the first category of question we talked about was the types of solid question. That is basically getting removed and replaced with the periodic table trends. So that's the first question you're going to get. Why can't I spell periodic? I don't know. Let me just look it up real quick because my brain's farting. There, periodic table. Thank you. I don't know why. Every so often my brain decides it's not going to work today. There we go. There. Focus. Okay, periodic table trends. And like I said, that more or less replaces your types of solid questions. We're just looking at patterns in the periodic table and why they have those patterns. The nice thing about this is there are multiple categories for the periodic table trends and what you're going to look at, but the background answer is more or less the same. So you can learn the same answer and apply it to lots of different examples. We will talk about this one this week. The next one you have is your Lewis structures, shapes, and polarity. Which is exactly what you guys had last year. This one, what was I going to say? The only difference between this one this year is that you're going to be talking about larger molecules. So we're going to be doing the extended octet. You're going to do some bigger things and you're going to learn some new shapes. That's the main difference with that one. So it's just a nice little bridge up from that. Something that does kind of pop up between the periodic table trends and the Lewis structure, it's kind of hard to place it. And this is kind of like a leftover remnant from the types of solid question is you're going to get a question on like boiling point and melting point, or attractive forces, and it kind of falls in between these 2 categories. It kind of depends on which section they put the question in, but expect something on attractive forces. Basically talking about melting point and boiling point. So it's kind of a weird orphan bit of a question. And the last thing you're going to get is your calculation-based question, which is going to be your enthalpy. Again, the calculations are going to be slightly different from what you guys have done last year, but still kind of similar. One of the things we'll talk about is Hess's law. So it basically replaces what you would have done the calculation-wise last year. But they can technically ask you questions from last year, just FYI. I have seen it very randomly pop up where they ask you to do a bond calculation question. I don't know why they stick it in there randomly. They just do. So just be mindful that it's worth reviewing your stuff from last year to do the stuff for this year. So Hess's law is something that comes up, and the other thing that'll come up is like heat capacity of water and doing thermal energy. They will ask you to do different versions of it. So they'll ask you to do like mixing two solutions together or heating something, and et cetera, et cetera. But that's kind of the three main categories you're going to get for questions. The other challenging thing about thermo is that you have to be good math-wise for this question, and you have to be good writing-wise for these two questions. So that is kind of the downside to thermochemistry. Yes, it's easier to rote learn. Yes, it's easier to get the achieved on, but in order to get excellence, you really need to know how to do good writing because there's a lot of writing structures to it, and it's also going to require you to have good math skills as well. If you have good math skills, this question here should be an easy excellence point because, again, there's not a whole lot of explanation required to it. They just check to see if you have the right math answer. So that's kind of the pros and cons that you're weighing up between these two externals. So I'll leave it there for now. That's just giving you the overview, and hopefully it helps you guys make some decisions already hearing what it's going to be like. So what I want you guys to move on to next is some SciPad pre-learning, just to kind of get an idea of what I'm talking about today with the electron configuration and why I've been lying to you for years and years and years. So these are the SciPad pages I recommend you guys do. Again, like always, you don't need to complete all of them. It's not a tick boxing exercise. It's just to help you understand it. The moment you understand it, move on to the next page. The other thing I want to point out to you guys is that the SciPad actually goes further than what you need to know for the exam. So don't stress if you don't understand things. Let me show you what I mean. I think I've linked it on the Google Classroom page. Sorry, the Google site. Chemistry. Okay, so I've linked the collated questions from No Brain Too Small on atomic trends. I just want to show you guys as a first step, though, what the electron configuration question is versus what you're actually doing in the SciPad, just so you guys don't overdo it. We're ignoring all the written long answers. We're just talking about this bit here. So this is what I'm talking about for electron configuration. It's kind of like level 1 acids and bases when you were doing the 2882 stuff. It's just a little bit harder because now you have to put in the S, P, and D notations. This is only an achieved point, so don't stress too much about it. That's why I'm only doing one lesson on it. It's a lot of learning for a very small amount of points. I'm very sorry for that. It does help, though, with the periodic table trends, so it's worth doing. All right, cool. I'll give you guys some time to work on that, and then I will do some notes so we can do some gimme kits and things.